Hello and welcome back to another episode of Math with Son. Today we are going to be finding the sum of an arithmetic series. So let's get into it. Alright, so there are a few different ways that this could be presented. It could be presented quite simply like 3, let's go with 7, and then 11, which is an arithmetic series we are adding by 4 every time. And I could say find the sum of the first however many terms. So we could find the sum of the first 3 terms. We could do 3 plus 7 plus 11 and just add them together. But if I said find the sum of the first 25 terms, that would take quite a bit of time, especially if I said like 125. All right? So in order to do this, I will need to utilize first my a sub n formula, a1, n minus 1 times d, and get the 25th term. And then after I find the 25th term, then I can use my sum formula, which is n over 2 a1 plus an. All right, so it's a two-parter. You got to use the first one and then use the second one. There is a formula that's longer that combines the two. I don't really like using that because I like the idea of finding the 25th term and then using it. So what you can think of, like this whole thing is an. So all of that could be used there instead. But I'm going to do it as 2 steps. First, we're going to find the 25th term. An, the 25th term, will equal a1, 3, plus n minus 1 would be 25 minus 1, times my difference. Well, we are adding by 4, so my difference is 4. And that would get me either a sub 25 or an. It depends on your philosophy, really. We're going to do that math right there. We got 3 plus 24 times 4. 3 plus 24 times 4 is a fun number. It's 99. And now we're going to use the 99 in the sum formula. So we already have everything we need for the sum formula except for the a sub n. So we needed to find that first. So we have the sum of the first 25 terms is equal to 25 divided by 2, because the n is still 25. A1 is still 3. That's still our first term. But now we have that 25th term, which happens to be 99. So our sum is equal to 12.5. That's 25 divided by 2. 99 plus 3 is 102. And we multiply those. 102 times 12.5 is a big number. It is 1,275, which is definitely not something that you would want to add up by hand. Like if you added up 3 and 7 and 11, the next term 15, the next term 19, and then just kept going all the way to 25 terms, you would end up with 1,275. All right? So this can be presented a few different ways. All right? This is one of the ways that can be presented, but it could also be presented in a slightly different way. So let's look at that. Let's say that we have, negative 2, and then negative 5, and then negative 8, and then some dots, and then a negative 20. Okay? So here, we actually know that we're looking for the sum if this is the last term. We want to find the sum of all of these terms. But that's the last term, which is in a way our a sub n. And this negative 2 is our a sub 1. Well, what's missing? In order to do the sum formula, we have n over 2, a1 and an. What's missing is the n. We don't actually know how many terms are here because there's this dot part. Now you could figure it out. You could kind of figure out how many terms there are by just adding. We do know the difference is what's going down by 3 every single time. So the difference is negative 3. And you could go and subtract negative 3 and subtract negative 3 and then just count up all the numbers. You could do that. Because right now we have 1, 2, 3 terms. I'm betting there's like 5 in between that and then negative 20. So the n is probably around 8. Okay? But you could also, again, utilize your a sub n formula. a1, n minus 1 times d. You could utilize that. Because you have almost everything. You have your last term is negative 20. You have your first term is negative 2. You don't have your n, but you do have your difference is negative 3. So you could distribute the negative 3. You end up with negative 3n plus 3. So I wrote plus negative 3n. I could have just wrote minus 3n. Combine the negative 2 and the 3. Negative 2 and 3 makes 1 minus 3n. I just wrote minus 3n that time. Subtract 1, subtract 1. Negative 21 would equal negative 3n. And the n has to be a positive whole number when you're solving. Why? Because you can't have 3.5 terms. You have to have a concise whole number. And it can't be negative 5 terms either. It has to be a positive number, and it has to be a whole number. So my n is 7. Now that I know my n is 7, I actually have everything I need over here. Because I had my a1, negative 2, from the beginning. And I had my a sub n, negative 20, from the beginning. The only thing that was missing was the n. And now I have it. It's 7. So I'm going to plug that in. 7 and the a1 and the an. And I'm going to solve. I get 3.5 times negative 22. 3.5 times negative 22 is negative 77. And that is the sum of the first 7 terms, or more importantly, it's the sum of this set, which went from negative 2 to negative 20. And if we were to add all of those together. Okay? So, that's going to do it for this episode. There is going to be another version of the arithmetic sum, but with sigma. So if you're looking for that, the ones with the big E, that's coming up next. And then we're going to have another episode that's going to involve just randomness, that involves solving for indicated values and just using the formulas to your advantage. All right, that's going to do it for this episode. Until next time, I will see everybody later.